All right, folks, it's Bass Action, back in action here. In this video, we are going to go through more of our adding and subtracting of vectors. We're going to look at another new vocabulary word called a unit vector, and we're going to look at the angle of direction of a vector. So a lot of things we're going to cover here. This first part is going to be pretty straightforward because we've actually already done it in the last video. So now we're going to do our adding and subtracting of vectors without an actual graph, okay? So I personally like to take these two vectors and I like to write them out before I really get too far into this. So I like to write out what would negative 5v of my v vector look like, and that would be a negative 25 and a 15, multiplying each of those components by a negative 5. Then I would go ahead and I would write out my 3w. Now, if you wanted, you could use a negative 3w. Okay, so you could do the negative and then you would add your components, but I'm going to go ahead and just do the 3w. So if I take my w vector and I multiply that by 3, that's going to give me a negative 21 and a 12. So now, if I want to actually do then the actual addition, I'm going to think about my algebraic component first. So my algebraic vector would simply take the negative 25, and I'm going to do minus the 21, so that's going to be plus 21. And I'm going to do my 15 minus my 12, because I was supposed to be subtracting those. So my algebraic vector is now going to become negative 4, 3. If I wanted to write that in what was called that component form, we touched on this at the end of the previous video, its component form would say that we're going to rewrite this now with those values as coefficients. So negative 4i, and then it's going to be plus 3j. Okay? So we can repeat that process over here on part B. I personally like to write out this negative 4v vector first, and that's going to give me an 8 and a negative 12. And then I like to write out the 2w, and that's going to give me a negative 14 and an 8. All right, now to do the algebraic vector, and you've got to be comfortable with both forms. On our algebraic vector, we're just going to add those. Our problem says we're going to add them. So we're going to have an 8 minus a 14 and a negative 12 plus an 8. That's going to give me a negative 6 and a negative 4. So that's going to be our algebraic vector. Our component, because we want to be comfortable with both forms, is going to be a negative 6i minus 4j. Okay, now a unit vector is not going to be that much different. Okay, a unit vector is going to have a magnitude of 1. So, and it's going to be denoted with a u, okay, and its magnitude will always be a 1. The unit vector, we find it simply by dividing each component by the magnitude of the vector. And we're going to find magnitude exactly like we did in the previous video. So we're going to be working with in both these problems, we're going to be working with these vectors from up here. So our magnitude from up here is going to be our square root of 16 plus 9. That, of course, is going to give us a 5. Now, the unit vector, what we're going to do is we're going to have our 1/5. We're going to have that algebraic vector of negative 4, 3. And then we would want to think about distributing this. Now, sometimes you'll see it factored out. We specifically want to distribute it definitely when things could reduce. But our unit vector would be a negative 4/5 and 3/5. Okay? We can do the same thing over here. We can find our magnitude. It's going to be our square root. We're going to go grab our numbers from up here. That's going to give us a 36 plus a 16 is going to give us a square root of 52. And of course, we always want to simplify our radicals, so its magnitude would actually be 2 radical 13. Okay. Now, let's do a quick little check here. Oh, let me write this unit vector here. So then my unit vector would be my 1 over my 2 radical 13. And then my algebraic vector, of course, was my negative 6, negative 4. Now, if we distribute this, what we're going to get is a negative 6 over 2 radical 13 and a negative 4 over our 2 radical 13. And we can see that things are going to reduce quite nicely here. And we would even probably want to rationalize these. So if we wrote this in our final rationalized form, our unit vector would be -3 radical 13 over 13 and -2 radical 13 over 13. That would be our unit vector, completely distributed, reduced, and rationalized. Now, let's do a little check here to understand how this unit vector actually does give us a magnitude of 1. If we go ahead and we do our magnitude on this new vector here, what we're going to have is we're going to have the square root, and we're going to square this -4/5, which will give us a 16 over 25, squaring the top and bottom. We're going to square this 3/5, that's going to give us a 9 over 25. Then that's going to give us the square root of 25 over 25, which is, of course, 1, exactly like we wanted it to be, okay? And that will always work out. Now, the next thing that we're going to do is we're going to find this angle between a vector and the x-axis, and this is called the angle of direction. You will generally need a calculator for these. So let's take a look at this angle of direction. I'm given this vector right here. Remember, this is a position vector, so it assumes that it starts right here at 0, 0 when we're graphing. When you have a position vector, it has to start at 0, 0. So this is going to be our terminal point. So we're going to go over -4 and down -3. 3, 4, 1, 2, 3. Okay. This is going to be that is our graph of our vector. And what we want to understand is, what is this angle right here? We're trying to solve for that entire angle right there. So what we're going to do is we are going to do our tangent. So it's going to be an inverse tangent, and we're going to do y over x, so -3 over -4. And of course, when we type this in our calculator is going to give it to us right here. So when we type this in our calculator, it's going to give us an angle of approximately 36.9 degrees. What we need to do, because we understand our angle is supposed to be in that third quadrant, is we're going to add 180 degrees to that to get that into the proper quadrant. So our actual final answer is 216.9 degrees. Okay? You've got to really understand how to graph these and how to move them into their proper quadrants. On our next problem, I've given it to you in the component form, but it is still assumed to be a position vector. So it's going to start here at 0, 0. This time we're going to go over 7 and down 3. And 1, 2, 3. That's going to get us to here. And we want to find this is our angle. This is the answer that we're looking for. So again, we're going to use our inverse tangent. And when we type this in our calculator, again, y over x, so -3 over 7. Our calculator, remember, is programmed with those inverse restrictions. So when we put this in our calculator, it's going to give it to us as a -23.2 degrees. But we want this nice positive rotation here. So we are going to add 360 this time to get that positive coterminal angle, and that's going to give us 336 degrees, 336.8 degrees. Okay, so you've got to be really comfortable with moving those things. Now, real quick, I just want to touch on these two notations. The reason this is called the angle between the vector and the x-axis is because when we do our algebra here, our inverse tangent, it's actually giving us the angle that's between that terminal side, that vector, and the x-axis. But our angle of direction is actually this full positive rotation. So that's kind of where these two names come from. So it is something to consider.